Alright guys, let's work on some of the problems. If you remember my last video, I had put that the whole trigonometry can be divided into 7 types of problems, and anything and everything that will come in the examination would be one of those problems. And the reason you need to understand the type of problem is not only for trigonometry, pretty much I'll be putting the same thing for every chapter, is whenever someone explains you a particular topic or a subject or give an example, normally students understand during that point in time, okay, this is how it is done. But when you remove the context and just mix up all the problems, and that too in the pressure of examination, you just give them a problem, students often get confused that how do I start? I know that I've done this problem, I've solved this many times, I know that I need to do something about this, but how do I start it? And that's where they kind of struggle in terms of the starting point, and how do they remember that how did they solve, or they might be starting the problem but they will not be able to travel it all the way through and stuff like that. And that's why this kind of trick helps, where if you understand, okay, the whole trigonometry is just having 7 types of problems that can come in the examination, and each type is related to certain things. And if you kind of remember, okay, type 1 is all about compound angles, I need to just apply those formulas and do that, and these are the examples I'm going to solve under that kind of type. If you kind of practice, or if you kind of remember that from that standpoint, during the examination, whenever a problem comes, you'll be able to quickly remember, okay, this problem kind of belongs to this type. Okay, and for this type, I think these are the formulas we need to apply. So that will just give a quick starting point. It will jumpstart your problem solving time, and then from there you can navigate. And within each type, I'm going to put some kind of examples, hints on how to remember that. Are there any tricks where you can easily memorize the logic and the strategy and keep on moving and kind of get the scores? That's kind of the overall thought process. So let's today just cover the first type of problem, the type 1 I call. And the type 1 problem, if you see, it's all about compound angles. They're also called as sum and difference formula. So you have to just remember that, okay, type 1 means I have to do something about the compound angle, or I have to apply the sum and difference formula. That's all. As long as you remember that, it will be very easy. Now, what is compound angle in a simple definition? See, the name itself, compounding, just has the meaning to it, and it just means literally compounding. So you have got two angles, A and B. Whenever you bring them together in terms of A plus B or A minus B, the algebraic sum, whether it's an addition or subtraction, the net effect is called compounding, and those two angles, or the A plus B or A minus B that I've written here, the trigonometric functions of those two angles, is called a compound angle. So you might have a angle standalone, say as angle A, and you might have a standalone angle B. When you just combine those two, A plus B or A minus B, in terms of trigonometric function, they are called compound angle. And the formula that is used to derive the value of this compounding, like I mentioned here, you're trying to determine what is the value of cosine of A plus B or cosine of A minus B. Similarly, what is the value of sine A plus B or sine A minus B, or tan A plus B and tan A minus B. So if you see here, I am trying to compound or add or subtract A and B, and I'm just trying to apply those three trigonometric functions here. So whenever you apply the trigonometric functions on a compound angle, whatever formula you get, as the name suggests, sum or difference formula, that's how you need to apply it. For example, you're going to use either a sum formula whenever there is a plus sign, or whenever you're going to use a difference formula whenever there's a minus sign. So cos A plus B kind of is a sum formula, whereas cos A minus B is kind of a difference formula. So kind of that's kind of the high level summary of what is a compound angle, and what is a compound angle and what does it mean. And anytime there is a question on compound angle, you just need to remember that you have to apply a sum or a difference formula. That's your starting point. That's your trick. Normally in the previous syllabus, there used to be questions for a couple of marks, 2 marks, define compound angle. So you can just score it easily if you just remember this definition. But I think the new syllabus, I don't think they're asking it yet. At least for the last 4 years, I've saw the question papers. They're not asking it. So I don't think they will ask it. And the only thing is, also in the old syllabus, there were questions, or within the syllabus, it was within the scope that they can ask you to prove this formula. Like, how do you know that cos A plus B is equal to something? What do you have to prove the left hand side is equal to right hand side. But in the new syllabus, I don't think they're asking, which is a good news. So you have to just memorize this two formula, and there are zillions of formula. But if you just memorize this two, all the formulas can be derived based on this. And for the construct and for the explanation of type 1, don't worry about tan A plus B. We are going to cover a different segment. There's a different type which is kind of dedicated 100% to all kind of tan problems. So you don't have to really worry about the tan problems right now. Just focus on the cos and sine problems for this. And the trick to memorize this formula is for the sine function, sine A plus B. Okay, so what's going to happen is you first write sine A cos B. Okay, so you have one function of sine, one function of cos, and then you just cover the other functions, because if you cover sine A here, then you cover cos A here, and if you cover cos B here, and then you cover sine B here. And the sign, whether it's addition or subtraction in the middle, will always be what is given in the actual equation on the left hand side. For example, if the left hand side says A plus B, then it's going to be plus here. If the left hand side says A minus B, then it's going to be minus here. So that's how you kind of remember sign. So the sine function. For the sine function, the center sign, positive or negative, remains the same as per the original formula, and it's kind of a mixed equation where on the left one side you have sine and cos, and other side you have cos and sine. That's how you remember. Whereas for the cosine A plus B, there are two differences. So if you remember the sine, you can easily remember the cosine. So you just remember one of it, and then you can remember the second one. For the cosine of it, on both the sides it's cosine, on the other side it's both are sines. For example, cosine A plus B, on the left hand side of this equation, or on the left hand side of this sign, the algebraic sign, you will have both the cos functions. On the right side is both the sine function. That's how you remember. And the sign, the positive or negative sign, will be the opposite of what is given in the left hand side of the actual form of the actual compound angle. For example, the compound angle says A plus B, then you'll be using here negative. If the compound angle says A minus B, then you'll be using positive. So that's how you remember. So in the case of cos, the compounding sign changes, whatever is that's opposite, like I've written here. For the cos sign, reverse the left hand side and the right hand side. And for the sine, the algebraic sign, the compounding sign, plus or minus, stay the same, and but it will be crisscross. You will have a sine and cosine function on one side of the algebraic sign, and the other angle of cos and sine on the other side. So that's how you remember. So you just remember these two functions for now, and I don't think, like I said, they're not going to ask you to prove. And for the tan, we'll come back to into a different type altogether. So with that, let's see if we can easily solve the problems that come in the exam for type 1, assuming that now you know these two formula. Okay, all right. So before you come and solve the problems applying these two formulas under the type 1 compound angles using sum and difference formula, I would like you to have a refresher on few of the topics which will help you understand it better. So first, let's understand the concept of terminal angle. We would have seen that in the previous videos, but let me just do a recap. And in case I have not covered it elaborately or in detail, you can use this kind of video to understand what the terminal side. So like the name indicates, if you see, this is the x-axis and this is the y-axis on this diagram. And this is your angle theta when you are moving it anti-clockwise. When you move anti-clockwise, if you remember, it's going to be positive, and if you move clockwise below the x-axis, the angle is going to be negative. But regardless of that, whenever you try to move an angle, and wherever the angle stops, and then you draw a side on that, for example this side basically tells this is where the angle stopped. That side is called the terminal side. And like I said here, the ray where measurement of an angle stops or terminates. So this is the ray, and the angle in this case moving anti-clockwise stops here, and this is called as the terminal side. Likewise over here, the ray is below the x-axis because we are moving clockwise, and this theta is where this angle stops. So wherever you have a ray, if you draw a ray where the angle stops moving, that side is called the terminal side. And I'll tell you why this is important, because as I said, in the old syllabus they might ask you a question, what is the terminal side, and in the new syllabus they may not ask the question, or they have not asked it yet. But what you need to understand is, based on this you'll understand some of the other concepts, so it's better to have a refresher on that one. So now that you know what is the terminal side, let's kind of quickly go into the second set of the refresher. So you remember this kind of unit circle concept from the previous video and the previous explanation that I did, what is a unit circle. And then you have this, and we also understood that how this kind of table was populated based on this unit circle. But there are something peculiar that I want you to highlight, and some of these things are going to be a repeat and refresh of last video, but I want you to understand there is the peculiarity. So if you see here on the unit circle, so the unit is divided into four quadrants. This is quadrant 1, this is 2, this is 3, and this is 4. Each is 90 degree. And if you see the value of the functions, it just goes from 0 to 1, and then 1 to -1, and then again to 0, and again to +1. And what is peculiar about this is, if you see here, this is just sine 30. Okay, and if I say sine 30 is equal to, what is the value of sine 30? Half. If you see the table, this is sine here and this is 30 here, so this is half. So if I say, if sine of an angle has a value of half, what would be the angle? Okay, if I say that, what would be the angle? For example, I've given it here, sine of A is equal to half. What would be the angle? Could that mean that A is equal to 30 or A is equal to 150? Because if you see here, sine 150 also has a value of half. If you see from the table, sine and 150 also has a value and half. So what it means is, sine 30 is equal to half and sine 50 also is equal to half. So if someone gives me that a sine of an angle is half, just say someone just gives you this this portion, sine A is equal to half and not the rest. How can you tell whether A is 30 degrees or A is 150 degrees? Because for any given value or any given solution, any given sine function, there could be two angles or two solutions that are possible. And then how would you know that? And the way you will know that is, you have to figure out where the angle lies. You have to see the clue or the hint in the question, or you have to ask yourself, have they given me anything to tell where the angle lies? If the angle lies in quadrant 1, then the value of angle A is 30 degrees. If the angle lies in quadrant 2, then the value of sine is 150 degrees. And that's pretty much true for all the trigonometric functions. So what you understand is, for any trigonometric function or any value of trigonometric function, any given value, there could be two possible angles for the trigonometric function, and based on which quadrant does the angle lie, you will have to figure out what is the true value of that angle. And since all these values are getting kind of repeated, even if you see here, come down here, sine of 210, if you see here 210, it's not here, but if you look at the unit circle, 210, the value is minus half. And similarly, if you come here, sine of 330 degrees, the angle is the value is minus half. And if you remember, all the y coordinates pretty much correspond to the sine value, and that's how I'm trying to determine. So you have half and half here, which are set of positive values, and then you have negative half and negative half here, which are set of negative values. So like that, you have got two negative values. And if I say sine of an angle, let's say instead of saying sine of A is equal to half, let's say if I say sine of A is equal to minus half, how would you know whether A is 210 degrees or A is 330 degrees? So likewise, if you see, for any value, there could be to any given value of the sine, there could be two possible solutions or angles. And based on which quadrant it is, which quadrant the angle falls, you have to figure out where it is falling. So that's the overall concept. So based on this, we don't need to know each and every value of this. Remember, if someone asks you what is the angle of 225 degrees or 220 degrees, it's very hard for you to memorize that, or it's very hard for you to calculate that, even whether using calculator or even using solving without calculator. So what the trick here is, what the mathematicians have found is, since the values keep on repeating, Why do we even have to worry about the remaining quadrants or any angle more than 90 degree? You just focus on all the angles between 0 and 90. Both 0 and 90 are included in that. And if you know the values of some of the angles, given any angle larger than that, or given any value in any of the quadrants, if the value is given, you can figure out the angle because you know that the angle is getting repeated, and you know what is the angle of the corresponding angle in the first quadrant. Or if they have given you the angle, then you know what are the potential values of that. And what does that mean by that? For example, I can easily remember sine 30 over here is equal to half. Here sine 30 is equal to half. I can easily remember that. But if you ask me to memorize what is sine 50, although I know it half right now, but I would not be able to remember all the values. But I don't have to remember. So what I can do is I can simply say, okay, sine 150, I need to figure that out. I know that sine 50 has a partner somewhere in the first quadrant where the value possibly could be the same. And if I know what is the partner's angle, I know that sine 150 will have the same value. So in this case, uh, the, the partner for 150 is 30 degrees, and hence sine 150 should be half. And that's the simple logic. And if I'm moving down, if you have to apply the cast formula, where you have cast is like C is in fourth quadrant, C A S T. If you apply that formula, I know that sine will be always positive in these two quadrants, and sine will be always negative in these two quadrants. So if I have to figure out the value of, say, sine 210, which is a big degree, but I don't have to really calculate that because I know the 210 degree has a partner in this first quadrant for which the value is going to be the same. And since 210 falls in the third quadrant, and by the cast logic, I know that sine will always be negative in this. If I can get who's the partner for this 210 in this first quadrant, get that value and just make it negative, then I can get the value here. For example, for the 210, the partner angle is 30 degrees. 30 degree has a sine value of half because sine 30 is equal to half. So I know the value of 210, the sine 210 is going to be half. But I also know that this 210 is in third quadrant. By applying cast logic, I know that sine value in third quadrant is always going to be negative, and hence the value of sine 210 is equal to minus half. That's the overall logic. So that gives us an interesting concept. So all this time I was using the analogy of partner angles. So whatever angles fall within the first quadrant, based on which you can refer and compute the value of the other angles. So all the angles over here, the partner angles, are called as reference angles over here, like I mentioned here, right? So reference angles. So that's kind of the concept I wanted to introduce. So now you understand what is a reference angle. I've just written it here. So a reference angle is any angle that falls within the first quadrant, having a value between 0 and 90 both included, like I mentioned it here. It is always less than equal to 90, and it is always positive because we don't have to worry about whether it's positive or negative, because once we get the value and we apply the cast logic, we can figure out what is the angle. The cast logic will tell you whether it's positive or negative, so you don't have to really worry about whether the reference angle, what is the value of that. So that's the reason we can assume, since all the reference angles are going to be in the first quadrant, all the values are going to be positive, and we just need to know that once we get the value, you apply the cast logic to determine whether it's positive or negative. That's one thing. And how do I know what is the reference angle? That's the biggest question. So over here, I'll come to that in a minute. So over here, I'm just calling what is the reference angle. So if from this unit circle, I have kind of sliced out the quadrant 1. This is the quadrant 1, just 90 degrees. And like I mentioned, it's always less than or equal to 90 degrees. And any angle that kind of falls within this area of quadrant 1 can be called as a reference angle. And normally we don't work with odd angles. It's always 30, 45, 60, but it could be 65 degrees, it could be 20 degrees, anything that comes within this. And if you see the type of problems that we are going to solve that comes in the exam, it will be always odd angle. But the beauty is that you don't have to worry about that, since as long as you know some of the values of these angles, And if the angle is pretty much straightforward, 30, 45 and 60, pretty much these are the three angles that you will get, because the values of the other two angles 0 and 90 is very easy, because the sine is going to be 0 and 1, the cos is going to be 1 and 0. You just have to remember these values. So any angle that falls within this portfolio, 30, 45, 60 or any other angle, is called as a reference angle. And if anyone is asking what is the measurement of a bigger angle outside of this, as long as you know what is the reference angle for that particular angle that is in question, you can calculate the value. That's what kind of I've shown. But how do I know, or how do I compute, given an angle, what is the reference angle for that? And that's what is the trick about, and that's what your questions will be asking you to do that. So for that, I've kind of painted a picture here. I hope you guys can see that. So if you see here, the concept is of the, I'm just going to explain the concept of a reference angle here. Uh, so if you see here, let's take quadrant 1. In quadrant 1, the reference, the actual angle, let's say the actual angle is called standard angle, like here, which is in green, and let's say the reference angle is called as theta prime, which is in red. So if you for the quadrant 1, the reference angle and the standard angle are going to be always the same, so you don't have to worry, because for quadrant 1 we know that the whole reference angle is in quadrant 1, so we don't have to worry. For quadrant 2, if you see, if someone is giving you standard angle, let's say someone is giving you 150 degrees, like for example over here, if you see someone is saying that, hey, the standard angle is 150 degrees, I want you to find the value of 150. I may not know the value, but I know that if I find the reference angle for this angle, I'll be able to possibly compute the value of 150. So in this case, this green color over here is the standard angle over here, if you see 150. And now how do I compute what is the reference angle? So the logic to do that is, if you see here, which I did not explain for a reason, reference angle is always with respect to kind of the x-axis. If you see here, right, that's kind of the axis. You always have to determine the reference angle, the smallest angle that the terminal side I explained you earlier. This is the terminal side, right? So whatever angle, the smallest angle the terminal side forms with an x-axis is your reference angle. So in this case, if you see this red color, this is your terminal angle over here, terminal side, and the smallest angle that it can form with x-axis, it has to be always x-axis, is this way, because this way is a bigger angle and this way is the angle that they're given. So this is the only way that it can form a smallest angle with the x-axis, and that's called as the reference angle. Similarly over here, if you see in this quadrant, the green side, the standard angle goes all the way into third quadrant, right, all the way here. And if you see the red side, that's called as reference angle, because if you see here this diagram, this shows you how the triangle can be formed, or how the angle can be formed, right? Or let's say, let's take here in this diagram, for this third quadrant, the smallest angle, which is in red, the reference angle, is formed by dropping a perpendicular from the terminal side to the x-axis. This is the smallest angle. So whatever this angle is in red is the reference angle. And once you know the reference angle, you already know the value, because you know the values for reference angles very easily. And then from there, you'll be able to compute the value of the standard angle, or the actual angle that they are asking. Only thing is, you have to remember where the standard angle falls, because you have to add a positive or negative sign based on where the angle is. So first you have to find the value, and then you have to add the sign, positive or negative sign. And like that, if you see all here, this diagram, this kind of gives you how to draw a perpendicular from the terminal side, making the smallest angle onto the x-axis. So if it's first quadrant over here, like here, it's the same. If it's second quadrant, this is your terminal side, you drop a perpendicular, this is your right angle, and this is your reference angle. Similarly for third quadrant, and similarly for fourth quadrant. And if you kind of imagine the way that triangles will look like, so the green, the red, the yellow, and the blue are kind of the smallest angles in the respective quadrants with the x-axis, and these four triangles that I called out are called as reference angle. That's the whole concept. So these angles are called reference angles, like I mentioned here, over here, and over here, the red side. And these triangles are called as reference triangle. So anytime you want to find angle value of a bigger angle, the first thing is you just make the reference angle, or draw the reference triangle, find out the reference angle, and then you can get the value. For example, over here, if you see, I'm trying to find out the value of, let's say, cos 210 degrees. Okay, I just want to know the value of cos 210. The first thing is, I know that cos 210 should be greater than 180 and less than 270. So it's going to fall in quadrant 3. So I know that. So in quadrant 3, if I have to find the reference angle, first I need to draw the reference triangle over here, the yellow one. So I've drawn the reference triangle because this side is my terminal side, and this angle over here, if you see this angle here, over here, over here, that's my reference angle. That's what you're getting it here, sine 30. So I know angle 30 is the reference of the bigger angle, the standard angle 210. And if I know the value of angle 30, I can get to know the value of the angle 210, and then I can apply the cast logic to apply the sign, the positive or negative sign. So that's the whole logic of reference angle and reference triangle. And the good news is, none of this that I told you till now, none of this, they're going to ask you in the exam. These are all just concepts, and I'm trying to explain it to you because I want you to do some checks while you solve the problems using this, which will confirm that whatever final answer you're getting in the examination is the right answer, because you can easily verify that. There is no other way to verify that. If you don't know this concept, you will be struggling to verify that whether whatever you have got is right or not. And with that, let's jump into some problem solving.